Right. We've done mean, median, mode, and range last lesson. Today we're going to look at graphs and try to read information from the graphs. There are lots of different types of graphs. So the first thing we're going to do is go through some of the different types. The first one that we have here is a histogram. That is what a histogram looks like. You can see at the top here, there is the raw scores that it represents. So there's 2 ones there, which is why it goes up to a frequency of 2 for the one column. And you can see for a histogram that the columns touch each other. The numbers go up in a nice scale up here. So 0, 1, 2, 3, 4, 5. And it says the data is grouped into separate, distinct groupings or categories. Okay, so that's a histogram. Then we have a column graph, which, very similar really with those vertical columns, but the differences are that there is space between the columns. And this is usually used for categorical data. Categorical is what we call like a word answer. You can see down here, they've asked people's hair color. Okay, so red, brown, blonde, or black colored hair. Whereas the other ones back here, we were talking about a score, we were talking about numbers. Okay, so we often use column graphs for categorical or wordy response data. The columns are a very useful way to show relative sizes of different categories. So you can see straight away that out of the people that questioned, most people had brown hair, and there was only a couple of people who had red hair. Next, we have a dot plot. We've seen some of these in our questions already. We know that each dot represents a score. And it can be similar to a column graph though, because you can see straight away that the one happened the most because it has the highest column, and you can see scores like 7 that didn't have any, and the ones that had smaller amounts. Pie graphs, or probably a better name is a sector graph, shows the slices, the pie slices show the relative size of the data. So you can see at a glance that the blue section there for the dog is the biggest sector, and so I guess is winning the competition for the favourite pet in that survey. All circles have 360 degrees in them. So if you needed to work out the fraction of people who liked dogs, for example, there was 120 degrees. You'd put that over 360, which simplifies down to say that a third of the people chose dogs as their favourite pet. Okay. You have to be careful when looking at graphs that some graphs are sometimes deliberately misleading. So if you look in things in magazines or newspapers, sometimes they're trying to give you a certain impression that something is a favourable result, and they're deliberately trying to present the graph in a certain way to make you think a certain way. So things that they can do is, it says in the dot points there, when only part of the scale is shown, the difference between the results may appear larger than it really is. So this happens a lot. So instead of starting at 0 and then counting up and using a proper scale, they might, if I was talking about house prices, for example, they might start the scale at 500,000, and then it makes it look like the prices vary a lot more because they seem a lot more spread out. Does that make sense? If one column has a different size or colour, so they deliberately make one thing look bigger to make it stand out more, that's a bit misleading. And when a pictograph symbols are not the same size, the larger symbol appears to have a higher value. Okay, so just little tricks they can do to make things appear a certain way. But here we go, questions for us. We're going to be given graphs in these questions, as I said, and we're going to be trying to answer questions from them. So this one, we have a histogram that shows the number of siblings that a group of people have. So if we looked at this first column, there were 10 people who had no siblings. Okay, so the number down the bottom is the number of siblings, and then the height or the frequency of it is how many people had that number of siblings. So the question is, how many people surveyed had more than 6 siblings? Yeah. So more than 6 does not include 6. It means they have to have 7, 8 or more. So we're talking about this one, and this one. Those people there that I've highlighted, they would be people that have more than 6 siblings. Now, 7 siblings, there was one person who had 7 siblings, because you read it off the frequency side, right? One person had 7 siblings, one person had 8 siblings, and one person had 10 siblings. So Ashley's right, there were 3 people who had more than 6 siblings. Okay, question B, what was the total number of people surveyed? 11? No, unfortunately. How are we going to work this out? I've said there was 3 people that had the 7, 8 and 10. It means I need to know the height of every column and add them up. Okay, so the first column is 10. The next one is 15. The next one over is 19. Next one over is 17. Then 9, 5, and 3. Okay, so we're going to add all those up, correct? Total number of people surveyed is 81, adding all those numbers together. Does that make sense? Okay, what is the mode? Now, that's a familiar word. What is our definition of mode? That's right. Which score in here has the highest frequency? That's right, because 19 was the highest number and that was a score of 2. So the mode is 2. And D, what is the range of family sizes? We also know what a range is. It is what's the formula? Okay, so in our data there, what is the highest number of siblings? No, not the frequency, the highest number of siblings. 10. There was one person that had 10 siblings, and then you minus the lowest number, which is 0, and that is equal to a range of 10. So people that were surveyed had between 0 and 10 siblings, right? So that's a range of 10. On to the next graph. We didn't see this one before. This is called a divided bar graph. And it's just one bar that's divided up in the proportion of how often something occurs. So this is the people watching different television stations. So you can see straight away, I hope, part A, which station was watched the most? The one with the biggest piece. Which one has the biggest piece? Channel 7. And then part B, which station was watched the least? Will be the one with the smallest piece. Good, yep, SBS. And how many people were watching the ABC? That's a bit trickier. We know that this represents 200 viewers. I'm circling that in there. There's 200 people watching. But I want to know, first of all, as a fraction, what fraction of people watched the ABC. So you would need a ruler for this. Does anyone have a ruler? You have one? Okay, so measure for me how long in centimetres is the ABC section. So measure ABC, what do you get? In centimetres. Yeah. 2 point. I got 2.2 when I did it. 2.2, yes. And then to make it a fraction, we want that over the total length of the whole bar. So you measure the whole bar. How long is it? I had 11.5, so I'll go with that. Okay, so how big, what I've just done is how big was the ABC section over the whole thing, but we're going to times that fraction by the 200 people that we know this represents. Okay, now if we're talking about people, can we have decimal places? So let's just say it's approximately equal to, so if you want, you could do the squiggly equal sign, so that means approximately equal to 38 people. Now, this is a picture that I've cut out of somewhere else. The numbers that we had, the measurements probably have changed a bit with me photocopying them. Okay, but that is how you would do it. Question, your turn. That was it. Your turn. Question 5, exercise 5.